Okay, guys, this may work out and this may not. Let's see what happens. So, need to add the date today. Oh, yes, I see what the problem is. Let's see if that fixes it. There we go. 12/5. Uh-oh. Changed up 19. There we go. So, arithmetic sequences. We're going to start with the FAIR model and kind of talk about what is an arithmetic sequence, what are its characteristics, what are some examples, and what are some non-examples. And basically, you guys have done these arithmetic sequences for, since you were in elementary school. But your teacher didn't call them that. What your teacher called them was, let's find a pattern. Can you predict what's going to come next? You're used to seeing a group of numbers, figuring out how they came up with those numbers, and then coming up with the next three. Well, we're going to take it another whole level, and we're going to say, okay, what's the 150th term? Now, you're not going to list out 150 terms to figure it out. We're going to teach you a formula so that you can find any number in one of these sequences. Okay, so the definition is, first off, what is a sequence? So a sequence is an ordered list of numbers. So there's some reason why those numbers belong with each other in the order that they're given. There's some sort of pattern going on. So to make it an arithmetic sequence, arithmetic sequences use addition or subtraction of a common or repeated value to get the next number. So put them together. Arithmetic sequences uses adding or subtracting the same number from each term to get to the next term. Okay, now that's arithmetic. There's another one that uses multiplication or division. Does anyone know what that's called, Trevor? Geometric. Now, we don't study that as much, but arithmetic fall in line with linear equations because of that constant value that they are growing by. So that's why it came into chapter 3. All right, let's talk about characteristics. Each value is called a term. And that word gets used a lot in math in several different places, okay? So each value is called a term. Now, there's a couple that we pay attention to. The first term, he's known as a sub 1. Any term, so it can be any term in that sequence, is going to be represented by a sub n, okay, where n is a number in the line. So if I wanted to find the 150th term, it would be the term a sub 150. So that tells me, look for the 150th term, okay? There's also a common difference we talked about. Oops. Between each term, or set of terms, between, let's say, between two terms. And we're going to use D to represent him. And as I mentioned just a moment ago, that D value is always constant, just like what else have we studied is always constant in a linear equation. Samson?
Variable?
No. Faith? Slope. Slope, or the rate of change, is constant. Otherwise, we don't get a line when we graph it. So the D value is always constant. So I'm going to talk about a couple of examples, pretty simple ones. Here's an arithmetic sequence, 1, 2, 3, 4, 5. And how we look for the pattern is we say, what do I do to 1 to get to 2? I add 1. What do I do to 2 to get to 3? I add 1. What do I do to 3 to get to 4? Add 1. 4 to 5, add 1. That is constant change. That difference is constant. So that tells me that's an arithmetic sequence. So consecutive integers. Kind of along the same line, this group of consecutive integers are consecutive even integers. How do I get from one to the next? Well, 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10, and so on. So that's telling me that the D value in this sequence is positive 2. Okay? So let's talk about some sequences that are not arithmetic, but they are sequences. 1, 1, 2, 3, 5, 8, and so on. Now, if this was arithmetic, to get from 1 to the next number, I would be adding the same amount. But let's look at what happens. To get from 1 to 1, I add nothing. To get from 1 to 2, I add 1. So right now, that tells me it's not an arithmetic sequence because it's different D values. So that's not going to work. In here, 2 to 3 is adding 1. 3 to 5 is adding 2. 5 to 8 is adding 3. So we have a bit of an issue. Now, this is actually a real sequence that occurs in nature. Anyone recognize which one this is? Faith?
The Fibonacci sequence?
Yeah, this is Fibonacci sequence. And Fibonacci went through and he studied nature, and a lot of time petals are in this pattern. The pine cone, I can't even think of what to call them. The little leafy looking parts that aren't leaves, but they're the pine cone things, you know what I'm talking about? I know that's terrible, I can't even think what it's called. Those followed this sequence. Lots of things in nature followed this particular sequence. All right, here's another one. Let's see, 2, 4, 8, 16, 32, and so on. So if this was arithmetic, I would see the same difference between the terms. So I add 2 to 2, I get to 4. From 4 to 8, I add 4. From 8 to 16, I add 8. 16 to 32, I add 16. So you can see this is not an arithmetic sequence. Okay? So if I kind of switch gears and I say, okay, that's not working, what else could I try? 2 times 2 is 4. 4 times 2 is 8. 2 times 8 is 16. 16 times 2 is 32. So this is not an arithmetic sequence. This is the geometric sequence that Trevor mentioned, where the pattern is multiplying or dividing by the same value. Oh, sorry, sequence. Okay, and when you're ready, I'm going to flip. You're not, because you're going to continue to write on this page. So now I'm going to unveil to you the mystery of how do we actually predict a number down the line without having to list out all those numbers. So is everybody good for me to go? Everybody good? Yeah? Okay. So what I have here is the closed foldable and the open foldable, and I'm going to go kind of back and forth and fill things in. But at the top, we're going to talk about arithmetic sequence formula. Okay. And we're going to talk about what is it. So the arithmetic sequence formula is an equation to calculate A sub n which is any term in the sequence, if A sub 1 which is the first term in the sequence, and D the common difference are given. Now this kind of reminds me of, for years when you guys were doing geometry, you'd find area of shapes. So let's say that you want to figure out the area of a rectangle. Well, we gave you the length and the width, you multiplied them, and you came up with the area. And then in the 6th grade, we started getting a little trickier and said, okay, what if I give you the area and the length, can you figure out the width? So now we're using the formula, but we're not doing multiplication. This time we'd have to divide both sides by that length number in order to get the width number. So we're also going to have some alternatives here. So the alternatives are, we could find the first term, so a to the first, if some term in the sequence, a sub n, and the common difference, the d, are given. So now we're not going to just solve for a sub n, some number in the sequence. We're going to find other things. And another possibility would be we could find n, which is how many terms are in the sequence, or d, the common difference between the terms, if the rest of the information is given. So we're not just going to go one direction when we solve this. We're going to go all sorts of different directions. Now, let's go to this guy over here, the foldable. Now, there were two of them that don't have flaps because there's some constants in this formula. One constant being equals, and the other one being plus. Okay? So I'm going to write the formula, and then we're going to write on the bottom one. So we're going to do everything on the top first and then fill in the bottom piece. So we have some term somewhere in the sequence. Now remember, sequence continues forever. That's what the dot, dot, dot means. Okay. And then we're going to have the first term. Ooh, that's a terrible color on that yellow. Let me get a darker one. A sub 1. So that's the first term given in the sequence. We're going to take how many terms there are and subtract 1 from it. That's n minus 1. And we're going to multiply that by the common difference. Now on my screen, these colors look a lot different than they do up there, but that's okay. Doesn't matter. So open up your flaps, and we're going to start with the a sub n, and that is going to be the nth term in the sequence. Now, some people can say that's any term. We're going to pick a particular term, and it can be any term in the sequence. Okay, so the nth term in the sequence, or any term. Our a sub 1, we just mentioned before, is your first term in the sequence. The n minus 1 is 1 less than the number of terms. And that's our n value. So basically what this equation is saying is even though our sequences are infinite, if I want to figure out what the 150th term is, we're going to kind of pretend that it ends at the 150th term. So that's our final term, basically, is what we'd be looking at. And then last, we've got the d is the common difference. Or what you're used to hearing it called is the pattern. So what is the pattern that leads from one number to the next? Common difference, and in parentheses, pattern. Okay, so we're just going to do 2 examples. Oops, let's go back to black. And our directions are going to ask us to solve, but they are going to give us specific information. So this one says, find the 21st term of 11, 8, 5, 2. So they're not going to just spill out information already labeled for us. We are going to have to go through the information and figure out what we have. So what sorts of things do we have? What do you see? What's one thing? Huh?
The decrease.
So you found the common D, and how'd you do that?
I said, if I subtracted 11 from 8.
So he's looking for here, if I subtract 3 from 11, I get to 8. From 8 to 5. If I subtract 3 from 8, I get 5. If I subtract 3 from 5, I get to 2. So he's just figured out the D. So D equals -3. What else do we know from the information given to us? We have a couple things. Faith, what's one thing?
N is 21.
Okay, so we know our n value is 21 because that's as far as we're going to go. Okay. What else? There's one more thing that they actually do tell us. What's another piece of our formula we know? Charlie?
Our first term is 11.
Yeah, so a sub 1 is 11. So the only thing that leaves us with is a sub 2, or a sub n, and that is going to be our 21st term, but right now we have no clue what it is. So we start with our formula, which is a sub n is equal to a sub 1 plus the quantity n minus 1 times the d value. And then we just start plugging things in. So we have a sub 21, because we want the 21st term, equals the a sub 1 is 11, plus, now notice, all of that I wrote in black is always there, okay? And the n number was 21, and the d value is the -3. And then we just start solving. So I get the 21st term is equal to 11 plus 20 times -3, which gives me 11 minus 60, which gives me -49. Now, for me to list out 21 terms would take too long. That, again, like I'm talking about on the test, when you guys use efficient ways, you take less time. So I was able to get to the 21st term in a lot less time than listing out that group of numbers. So that's your answer right there, is the 21st term is -49. Okay, second one. Which term of the sequence is 32. And here's our sequence. Negative 12, negative 8, negative 4, 0. So there's 4 things we need. I'm going to just write them out real quickly. We need a D. We need an N. We need an A sub 1. And we need an A sub N. Okay, what do we know? Trevor.
D is 4.
Okay, so as we are looking here, to get from negative 12 to negative 8, we would add 4. To get from negative 8 to negative 4, we would add 4. To get from negative 4 to 0, we would add 4. Sometimes that's the easier place to look, is where the numbers are smaller, there's a 0 involved, it's easy to find that. So, ooh, I did that all wrong color, didn't I? Try that again. Plus 4, plus 4, plus 4. So he goes here. Okay, what else do we know? Let's go with Arnav.
The first number of the sequence is negative 12.
Yeah, this guy right here, negative 12. Okay, what else? I'm looking for some people who have not participated. Eli.
32.
N is 32. Wants us to find the 32nd term. Or no, it's which term? Oh, that is the number that would be the okay. So that's this guy is 32. So our mystery number is this one. So we start with our formula. A sub n equals, and the reason why I start with the formula is because I want to memorize this formula, because on the test I'm not going to tell you it. So that's why I always start with the formula, and then it gets kind of stuck in my brain, which is good. So I'm just going to start plugging numbers in where they belong. So I get 32 is equal to, let's see, negative 12 plus the sum, or the difference, n minus 1, and the n value is what we don't know, so we're going to leave it as n, and then times the d value, which we said was 4. And then I just start solving. So 32 equals negative 12. I think what I'm going to do here is just distribute. So 4 times n is 4n, and then 4 times negative 1 is negative 4. I do see some like terms here, so I'm going to combine up my like terms, and I get 32 equals negative 16 plus 4n. Signs are the same, so I add. I want to get the 4n isolated, so I'm going to do inverse operations with a constant, so I add 16 to both sides. That gives me 48 equals 4n. I'm going to use the symmetric property and rewrite it as 4n equals 48. And then to get the n completely alone, inverse operations, I'm going to divide both sides by 4, and I get n equals 12. So my answer is 32 is the 12th term. So those are 2 of the types of problems you could be solving using this formula and the various information. All right?